Hey folks, I'm Aditya Bansal, and I'm currently a founding engineer at a company called Cortex, where we're building the future of internal developer portals. I actually got an opportunity to join as the first employee back in December 2020. So I saw the company go from 0 to 1 and then 1 to 100 quite literally as the company scales beyond 100 plus people. Before that, I was at another company called Curebase, where we were building healthcare trials, and I got a chance to see the company go from 0 to 1 as well. Basically, I've just worked at startups, which brings me to today's talk title, that is shipping observability in less than 2 weeks. Because many times at startups, we just didn't have the time to go and build a full SRE team. First off, why should you listen to me? To begin with, take everything I'm saying with a grain of salt. I don't claim to be an expert in the space at all. I've just been woken up enough times at 3 a.m. where I began to care about this, and I've been yelled at and screamed at by my CTO, where I was like, I should really begin to learn how some of this SRE thing comes together. And so I decided to learn something about how to take the first baby steps on the journey to observability. And with that, let me share a story. It was October 2023, and we had a string of incidents. And by incidents, a customer would ping us on Slack saying, hey, is your application down? Which would lead to an ad channel message from the CTO or another founder to the engineering channel saying, hey, what's going on? Which would lead to me or one of the other engineers scrambling to figure out what was going on. Are we down? Fully down? Is something working? Is nothing working? And more often than not, we would be fully down. Nothing would be working. It would not be a false alarm. And this continued to happen every now and then over a period of few weeks. And it wasn't like we weren't doing anything to catch things. We had configured our first alert on GCP, which was obviously misconfigured. So it would tell us when things were down. Just 8 minutes after the entire system had crashed. And we had also begun to make our product much more reliable. This entailed the senior most engineers taking to Notion, starting to track what metrics we need to track, how to distinguish between mission critical versus regular endpoints, what APM tool to use, etc., etc., etc. Except there was one problem. Our systems kept going down every single day. And one day, you know how founders and execs can be, this was the message that my founder sent me and the chief architect. Yada yada, something needs to drastically change. This is fucking insane that we're going down entirely and not just degraded performance. We need to be moving with more urgency on the alerting and monitoring thing. It can't just be a side project anymore. There was a lot more before this. There was a lot after this, but I'll spare everyone the details. Now, I don't share this to badmouth the guy. He's one of the finest founders I've worked with. I just share this to underscore the fact that when our customers were struggling and we were debating which APM tool to use, we realized we were doing something wrong. And one day I decided to just roll up my sleeve and say, fuck it, I'll do it myself, like Thanos. So over the next few days, rolled up our sleeves and started doing whatever it would take to get things back in order. And remember, this was pre-ChatGPT and LLM days. So we couldn't just ask an AI bot to give us an entire project plan or what could be done. But thankfully, by the end of the 2-week period, we had monitors that would catch a full service outage in less than 30 seconds, catch latency alerts on our mission critical endpoints and public APIs, catch errors on the same endpoints, also catch long overdue background jobs because our system really cares about those, and a lot more. Today, I'll share a brief view into what all we had to create, the lessons we learned, and how you too can begin your observability journey in less than 2 weeks. So let's begin. First off, I love philosophy, so some guiding principles to begin with. The biggest lesson I learned on the journey above actually had very little to do with observability. It had more to do with a value that I hold very close to my heart now, which is bias to action. We had spent multiple weeks trying to write down a perfect action plan of everything that needed to be done. But when push came to shove, we were able to achieve all that we wanted to in less than half that time. This brings me to my first principle, that is bias to action. A working solution today is better than a mythical solution in the future. So start with something today. And with that, let me turn this philosophical talk into an actual practical one. Real quick primer for anybody who is relatively new to the observability world. A rock-solid foundation is built on a handful of bricks, mostly logs, metrics, and tracing. So let's start with logs. Logs are an engineer's best friend, most helpful when debugging bugs, but shouldn't be discounted during incidents. And structured logging is where things get interesting, essentially logging on steroids. In layman's terms, this just means, hey, tag all my logs with this particular set of data. For example, say you're an e-commerce platform and you want to see the logs for any given user ID. Say you have a user named Bob with a user ID 1 in your database. To get structured logging in your auth flow, you can simply tag your logging framework to say, hey, tag all logs going forward with user ID is to 1. And now 100% of the logs that are initiated by any user flow that Bob starts will be tagged with that particular user ID. So when Bob calls and says, hey, I see this red looking error on your page that I can't buy my favorite pair of jeans, you can simply go to your logging dashboard, search for level is to error, user ID is to 1, and you'll see exactly the error that Bob is running into. Any modern language or logging platform has support for this, and we'll talk more about tooling and tech stack in just a minute. Moving on to metrics are a level above. Simply put, they are a numeric value showing the current state of one particular part of the system. So things like your requests per second, or percentage of CPU utilization, or percentage of memory used. Almost all startups I've observed, pun intended, do have logging set up. Most even have structured logging set up, but very few begin to invest in metrics or tracing. Now, this could be because this used to be very expensive, but that cost has come down dramatically, both in terms of actual dollar amount, but also in terms of engineering and human cost. With the advent of OpenTelemetry, it is very easy to get started with a base set of default metrics like the system and RPS and CPU, etc. But pro tip, don't just rely on system level metrics like the ones I mentioned, which brings me to my second principle, that observability is contextual. Observability for me is not the same as observability for you. My product deeply cares about background jobs because we ingest a lot of data from different integrations. But yours might be a financial product or an e-commerce platform that truly cares about real-time user latency. So get metrics that are very specific to your needs. Going back to the e-commerce platform example, a perfect example of a metric would be the success rate of the checkout button that Bob was trying to click, which can later be turned into an error alert as well. Moving on to traces. Traces explain the full story behind a single request. And I use the word request here very loosely. It doesn't have to be a web request. It could be a gRPC, a background job, basically any containable unit. But for our purposes, imagine a web request being made to post/cart/checkout. Behind the scenes, this might be a very complicated flow because it has to go through user auth, cart status and checkout logic, payment systems and gateways, user notifications, and a lot more. And anything could go wrong in the entire flow. Now imagine having a single trace which could point to every single function call made in the flow, the latency, whether it was successful or not, tied to your logs. That is the power of a good trace. What's more, if you have multiple service hops and network calls between these service hops, your trace could point out exactly which service took the longest or errored out. During a live incident call, this data is priceless. How many times have folks in the room caught an endpoint just making n+1 SQL calls in a loop? A couple of them. Yeah, logs and metrics would not catch those, but a good tracing solution immediately would point to the root cause. Now, usually the above three of logs, metrics, and tracing are super helpful enough if you assume that observability is the health of the systems and not the health of your product. Or if you assume that observability is only for backend engineers and SREs and not for every engineer in the room. I've also been there. But if you want to go an extra step and capture information about how folks are using your real product, invest in real user monitoring or Room. You know how traces explain the story behind a single request? Room literally captures the exact moment of how a user is using a product, surfacing the full user journey. So it'll capture button clicks, page crashes, console errors, API requests, everything that you would need. And it would also more often than not tie to your logs and tracing and metrics behind the scenes. Truly powerful for observing how users are actually interacting with the product. Now, I do want to caveat something here that if done incorrectly, this can lead to privacy issues. So before you go down the route of capturing real user monitoring data, I would recommend investing in anonymization and PII redaction to ensure that no user input data is leaking through the systems. Most Room products would give you the ability to do so very easily. One quick note before moving on that whilst I'm servicing screenshots from Datadog here, they're not really paying me anything. And that is just my tech stack. This is very much solved problem for every major language or framework. So for structured logging, Python has structlog, TypeScript has Winston, Go has Zaplog, etc. And for metrics and tracing, you can use OpenTelemetry. But if you really want to use an off-the-shelf product, you can just Google the term APM or application performance monitoring. It's very much it's a very competitive space, so you'll find solutions all around. All right, now that we have the dots or the data, let's move on to actually connecting them together, starting with configuring the alerts. Oops. If you're starting from scratch and you have 0 alerts right now, the first alert I personally recommend is a synthetic. Let's say you're a small startup and your service is deployed to api.company.com. A synthetic test is simple. All it will do is periodically hit api.company.com, pass if it gets it to 100, and fail if it gets anything else. That's it. It's that simple. You can configure it to be a lot more, but for simplicity's sake, that's all that you will need. And with one simple test, you can start capturing your entire service's uptime, which can eventually also be turned into an SLO. You know how earlier in the story, I mentioned our first alert was taking more than 8 minutes to tell us when the entire system was down? This was because it wasn't configured to be a synthetic. When we turned it, that 8-minute window went down to 30 seconds, that too in the worst case. More often than not, it would be significantly less than that. And with one small alert, that honestly took us less than a few hours to test and configure and get it right. We were confident about our uptime, or actually just at least capturing downtime. Now, while synthetics are a great starting point, they're often not enough. Most customers would not distinguish between your service being fully down and taking more than 10 seconds to load. So latency alerts are a must-have. This is where the metrics and trace data that we started capturing earlier come in handy. If set up correctly, you can now create alerts on a set of endpoints or your mission critical endpoints, however you want to filter those. And let's take a minute to go through the anatomy of a good alert. It includes 4 different things. Number 1 is just the detection method. If you're just starting off, I would recommend a threshold alert. This just says whether you want a value to be greater than or less than your configured threshold. But if you're getting fancy, you can get into change alerts, which compares your metric against the previous week or the previous year or anomaly detection. Just to be simple, we'll start off with a threshold alert. Then you define the metric and you filter it down. Let's say you have staging and prod. You don't want to get metric data or alerts for your staging environments. You can define the latency metric and filter it down to your particular environment. And the math around it. Are you looking at the max latency over the last hour, the average latency of the last 30 minutes? You get to configure that. Then you set the alert conditions, which is what threshold do I want, like after which I want the alert to actually fire. Finally, moving on to the data about the alert itself. So this will include all the runbooks and dashboards, all the data that you can provide to the engineer who's going to get paged, and also includes your notification channels. Do you want this to go to Slack or PagerDuty or other channels? And that's it. That's all you need to configure a full alert. And finally, completing the Trinity, moving on to error alerts. This is essentially the signal to noise ratio of your requests. What percentage of requests are creating errors or passing? The easiest to get started with for an error alert is just to take the same endpoints you took for your latency alerts and set the error rate to be the number of 5xx requests divided by the number of total requests times 100. And if it's more than X%, just fire a signal. Now, there are various other alerts that you can configure depending on the context of your business. You might want throughput or other kinds of alerts. Remember, observability is always contextual. If you really want to dig deeper, I'd highly recommend the Google SRE book on the subject. It's been a goldmine of data. I want to take a minute to highlight the importance of dashboards. You know how I said a trace tells the story of a single user journey experience? Dashboards tell the story of a given system. Let's say you've configured the alerts and now some poor engineer is getting paged at 2 a.m. Now what? They're new to the system, so they don't know exactly what to do. What information can your dashboard provide them so that they feel confident in dealing with the alerts? A good dashboard will clearly answer the following. Which of the above signals is currently struggling? So instead of highlighting 50 plus metrics on a large white screen, it would just be highlighting a handful of signals and big bright red colors if something is going wrong in one of them. Now, Everything I've spoken about so far has been about signals and dashboards and getting the data into a point where your pager is going on. But what happens when the pager goes off? At Cortex, when we were small, incident response looked like utter chaos. A customer would ping Slack, the CTO would ping ad channel engineers, engineers like me would scramble to figure out what's going on. We had no process. We just had a lot of adrenaline and energy. But over time, we realized that observability isn't just tools and energy, it's also culture, it's also systems. So we started investing in a much better incident management process, which included spinning up Slack channels per incident, writing short blameless postmortems, tying alerts to actual runbooks so that engineers could pick up an incident and not feel lost. I can't stress this enough. Data and tooling and APM, that's just the beginning. What happens after the pager goes off will determine the success of your team. All right, enough rambling, Aditya. What do we do with this? Let's talk about a real life playbook you can use to get started, combining all the things that we spoke about today. Number one, invest in a logging platform if you haven't already. Moving on to adding structured logs. Then ship basic system level metrics using OpenTelemetry. This is very easy to get started. After that, ship one product specific metric that is specific to your use case. This will teach you how to use your tech stack or language with OpenTelemetry. Moving on to alerts, just configure the first synthetic to start capturing your system's entire uptime. Moving on to latency and error alerts. And finally, connecting everything together with a minimalistic dashboard and one runbook. Now, none of this is perfect, but it can be done in less than 2 weeks, and that's the entire point. Which brings me to my third and final guiding principle, that observability is always work in progress. Perfect is the enemy of the shipped. I do want to make a small confession here. You know, how the title says you did one in 2 weeks, it's mostly clickbaity. It can't be fully accurate. Whilst yes, you can get a good 80% of the way there in a handful of weeks, to get to proper incident management process, it can take many months to even years. So over time, at Cortex, we've invested in a much better incident management process that is constantly evolving and includes fine-tuning alerts on a regular basis to keep the signal to noise ratio fairly high, figuring out how to handle alert fatigue to reduce engineer pain, evolving our technical tooling to handle an ever-growing number of services and metrics and data, and we continue to invest in more. So start with something and tell me the story about your observability journey next time we meet. Remember how in October 2023, our customers were telling us how broken everything was? Now, only a couple of years later, I stand in front of you feeling much more confident that if something truly terrible was to happen to our systems, I'll get a page in less than 30 seconds. Thank you. With that, I'll open to questions.
All right, questions. So you have showed the dashboard. And one of the problem I personally have is when we have too many dashboard, when something goes wrong, I have a hard time knowing which dashboard to look at. And the dashboard can be very long, maybe 100 graphs on that dashboard, like which one to look at. How do you solve that problem of locating the right dashboard?
That's one of the problems we had at Cortex as well, that we had no categorization of dashboards, and each single dashboard would have like more than 10 plus metrics, or sometimes 50 plus. Usually the best practice I've seen is tie a dashboard and a runbook to every single alert so that when a particular page is firing, they have at least a targeted entry point of what to start looking into. I've also started seeing that with dashboards, a lot of people now are beginning to add context and data on the dashboard itself. So not just metrics and signals, but huge paragraphs highlighting like what is going on. That's the biggest thing that we've seen so far that seems to help us. Hopefully that answers your question.
Thank you.
Yeah.
That helps.
When you're bringing observability into an organization, how do you help your users differentiate between what should be considered an alert and what should be considered an incident?
Oh, that's a great point. It's something that Cortex is beginning to learn right now. I think for us, the distinguishing factor is something impacting customers directly, or is something just impacting our systems right now, and just something to look out for. If it's impacting customers, whether or not it's a system that is down, it can be turned into an incident. It is usually a human intervention that leads to taking an alert and calling an incident on that alert. But by default, everything is just going to be an alert. So with very few exceptions. So the lifecycle usually is we have lots of alerts that we've configured around latency and errors, etc. They all stay as alerts to the on-call engineer. Depending on the severity, they might be daytime alerts only, or they might wake people up. And once the engineer has made the assessment of what the severity is, they can convert that into an incident. The only exceptions there that I can think of are synthetics. So if the system is fully down, that is automatically treated as an incident, but everything else is up to human judgment. And that's drastically reduced the noise and that the engineers were struggling with.
Hey, so my question is around like a scenario. Let's say a user wants to onboard a critical endpoint, API endpoint, and he's demanding the SLA should be 99, but this is the first time they're trying to onboard an endpoint. They don't know how it behaves or how it works. So what would be your take? Do you promise to the SLO what the customer is looking for, or do you give any strategies on increasing it like step by step or how it works?
To be honest, we're still learning about SLOs, but what I've seen is it's very dependent on your business and the kind of endpoint that it is. So depending on the severity, there might be different SLOs. So for us, for example, any endpoint that is considered mission critical would be auth and auth. So for that, the SLO needs to be much higher. And for everything else, it might be slightly lower. I don't know if that fully captures your question, but
So the next question is, let's take an example that yes, the alert has triggered that one of the API is down, API endpoint is down. Does Cortex go a step ahead in identifying like what was the reason for it? Was there any change rolled out, or was there any infra change that caused this? Or does it do any auto healing by performing any run command at the back end to break up the service before engaging the on-call engineer?
today, no, it does require the on-call engineer. We have auto scaling and auto disaster recovery of some sorts in place already. So if a node goes down, these Kubernetes will bring something up by itself. But by and large, it depends on the engineer to come forward and do the initial investigation. This is one of those areas where I'm fairly optimistic about the future. If you notice, I didn't use the word AI in my slides at all, but I'm going to use that in this answer. There's at least 10 different startups that are trying to build an SRE agent, and I'm really hopeful that somebody does that successfully, wherein they can do things like the initial investigation and triage of an alert much more quickly. I think it'll take some time to get there. I don't think it'll happen fully anytime in the next year or two, but eventually, yes, I think it'll get to a place where the initial investigation is a lot more automated.
Okay, thanks.
Oops.
Any other question?
Hi. When you create an alert, so for us, we are trying to pinpoint immediately where is the root cause of the alert, right? So we're gonna create alert in the database layer, APIM layer, in every layer that we can do, right? So when an issue will happen, it will all trigger, right? So how have you experienced that, and how you're making sure that an engineer will caught the root cause instead of the effect or symptoms of that?
Yes, it's something that Cortex also struggled with quite a lot. At one point, we had 0 alerts, and from that, we went to maybe 100 alerts, which led to a place where if anything would be down, we would get 10 plus alerts, and everybody would be very confused. What we've learned over time is to not create those many alerts. The number of alerts you need, especially if you're a monolith, is fairly low. It is on the order of single digits to low double digits, I would say. The second thing I would say in terms of alerts, keep that as close as possible to the end user experience. So if login is broken, then you might need an alert on the login system. The database alerts, usually what we do have database alerts and other infra level alerts, but they're considered lower level alerts that would go to the infra team. So if a full service outage is happening or API latencies are happening, they would go to the product team. So it's a little bit more distinguished between who is picking up the alert and they know how to act on that. So I don't know if that fully answers your question, but hopefully.
Just a follow up. As an SR, you need to know that there's something wrong in your product, right? So, for example, if these alerts go to your infra and you're not aware of it, then you're gonna struggle finding out what's wrong.
Correct. Which is why all the product level alerts, they're already tagged with, at least in our case, which team should be picking up and who is the responsible owner for it. That makes it easier, even if you're an SRE, to go and at least triage to the right person if need be. So I don't think the expectation as an engineering team grows can be, hey, anybody who's picking up the alert should be able to resolve that fully. I think in our company, what we're trying to aim for is they should be able to find the relevant person as fast as possible and maybe do the initial investigation. But after a certain scale, it becomes very impractical to expect the first person who's picking up the alert to know exactly what is going on. And usually this will also come up in the incident postmortem process, that if an alert was fired and it didn't really have good actionable information as to who owns the alert or where's the runbook, what do I do when this alert is actually firing, then it's something that we would discuss in the postmortem, which would naturally lead to the alert getting either scrapped altogether. That's something we're becoming a lot more aggressive about, or at the very least tuning it to be less false alarmy, or at the very least have information in the alert to say, hey, this is how you act on the alert when it fires.